Thanks for coming this evening. I do have a presentation prepared, obviously, but it's a small group. We can handle it informally. Questions or comments would be appreciated. I'd like to hear from you. I'm not exactly sure what everyone does here, so I think you do something different than I do. So I'd like to see your perspective on what I'm talking about. And I wish there was some way to say this stuff isn't relevant to us, and if you think of an easy way, I'll speed through it, or maybe it is relevant and I'll try to slow down. But anyways, here are my four topics tonight. I'm going to be talking a little bit about soil compaction, tree root cutting, soil moisture, and then if we have time at the end, a little bit different view of trees. We're going to start with soil compaction. Obviously, trees can be greatly impacted by compaction, limiting root growth, disturbing water movement through the soil. Typically, when we find compaction, it's associated with low levels of organic matter. Why is that? Well, soils without organic matter tend to be easier to compact, and often we're dealing with subsoils after grade changes. And along with that, since it's often associated with low organic matter, often low nutrient levels as well. So typically on these sort of sites, we're going to have compaction. It's going to impact the trees after the construction people are gone. And our job is trying to get that tree to survive, to serve the function that you left it there for. So this can be a real challenging situation for us. You know, there's some attempt at preventing damage to the tree's root system here. Do you think that that orange fence is doing its job?
Clearly it's being respected.
Yeah, clearly. Okay. They don't tend to work really well, and even if they were, I think that's not enough space, and I've heard you've had some talks about how much space. I'm going to show you from a root loss perspective how much space we think you should have. Often later on we'll start seeing dieback like this because of the root loss, so we're getting less water uptake. We'll start seeing dead branches, and ultimately we see a lot of this, dead trees on the site, and again those trees no longer fulfilling the prescribed need on that site. And a lot of that could be prevented by treatments. So this is a tree root growing through soil. It's fairly light soil over a compacted soil. So often we think about this as going out rather than down. But anyways, the root can just keep expanding like that, often forms a little bulb at the end. That's one of the scenarios. My next scenario here is that root, again, growing into not quite as compacted soil, and it's going to slow down a little bit, but continue growing at that slower rate. It's going to be a little bit harder to form the root hairs out of this, so uptake of water, nutrients and things like that going to be a little bit affected there. So we have some numbers on this as far as bulk densities, what our critical ones are. This was for pine, and again that critical bulk density right in that 1.4, 1.5 area. And there's some generalized tables or figures out there that show this, and I hope you're fairly familiar with these. In this figure, showing the critical bulk density level in red, overlaying the textural triangle, because the different critical levels are, of course, dependent on soil texture. But if you're going to pick one that works for most soils, and then that would be around that 1.45 to 1.5 bulk density level. But again, if you have a sandier soil, you can compact it to a higher degree without affecting root growth. If you're more on the clay side, it's going to take a lower level of compaction to affect those roots. Well, there have been a number of machines developed over time. The first one there in the upper left from the 1920s, newer versions from the 90s, and this very fancy one from our friends in Germany a very complicated looking machine, all designed to help alleviate the impact of soil compaction. We tested these machines. This is a cross section, the flag, a cross section of soil. The flag is where we put the probe down and injected a blue dye into the soil so we could see what happens with these fracturing machines. We dug them up. We traced that blue dye out in the soil to see what was really going on. And what we found was that these machines tend to create one fracture layer. It lifts the soil, and if you've ever been around one of these machines, they're very impressive because they'll like throw you up in the air when they put this high pressure air into the soil. But the problem is the soil settles right down. You have created this fracture, and that's a good thing, but you haven't affected the soil either above or below that fracture level. So that was one little test we did to see what happens, but we also took these to the field to compare some different methods of reducing soil compaction. I like to work in highway medians because we have the same tree planted down the road, usually heavily compacted, organic matter at our test site very low at about 0.6%. Bulk density was high enough, nutrient level, of course, low, and we were dealing with pears and crepe myrtles here. So our crepe myrtle, if you're not familiar with it, they call it a southern lilac. But so you'll see it as we go along. So we were comparing some different treatments. This research goes back a little ways. Wood chip, mulch, fertilizer. The grow gun was one of those air injecting machines. Radial trenching been pioneered here at the Morton Arboretum. Vertical mulching, a very old technique. Just rototilling, these were new transplants, so we could rototill around. And roots is a chemical treatment. There are a bunch of chemicals out there that tout that they'll reduce soil compaction and improve root growth in these situations. And then our control. So those are our wood chip. You know, we went curb to curb there, about 4 inches fresh out of the truck. The fertilization, sort of standard fertilizer procedures. We use the grow gun in this experiment using isolate, which is a porous material. I think they use it on golf courses some places. Does anyone use it, that material, isolate? Rooftop gardens or anything? Nope, okay. Anyways, that's supposed to hold open the soil fractures. Again, a porous stone that will do that. Radial trenching, again, developed by Gary Watson out at the Morton. And we were using a chain trencher here, about 4 inches wide, 12 inches deep, 6 feet long. And we were doing six per tree. We're using composted yard waste here from our recycling center, putting some fertilizer in there as well. So that's what our treatment looked like, the radial trenches. The trenches were backfilled in with soil and compost. And then the vertical mulching, again, sort of an old technique, 2-inch diameter holes, 1 foot spacing, filled them with peat moss and fertilizer. And then rototilling, again, we can do this where there aren't any roots, new transplants. We can go around them, loosen that soil. And again, we went about 36 inches around those and we're fertilizing along with it. The roots is a humic acid material, and there are, again, a lot of these out on the market that tout that they'll help overcome these problems with the soil. We soil injected that. We ran into a pretty serious drought that first year. The trees not looking particularly good. I'm not going to bore you with all the photos in between, but I did want to get to the data here. So we're looking at diameter growth over the 2-year period. You know, it depended a little bit on species here with the pear. The rototilling worked really well at giving us our greatest increases in diameter. The mulch by itself, good treatment there. And the trenching was good. These were significantly better than any of the other treatments that we applied. And again, a little bit different from species to species here. They're both very tough, very aggressive rooting species. So we were actually happy to see that change in diameter being significantly different. So the tilling, was a very good treatment, but we're limited on that one. We can't do it under established trees. Nobody does that, right, in this room? Okay. I've actually seen people do that. It's a terrible, terrible thing to do because it tears up the root system. But so we say you can't do that. So how can we do that without causing this excessive root damage? And this is where we developed this root invigoration process, where we can basically do the same sort of tilling that we did with the rototiller, except that we're doing it with high pressure air. So it's not tearing up the root system. We've sort of learned a lot since I did this video. We no longer do it this dry. It should be basically a dustless process. So do you see it sinking in there? So we've gone from a pretty heavily compacted soil to one that you'll sink into. So it's basically the same as rototilling, but with air. So what we do with this process is we tear up the soil first with the air tool. We till it, basically air till it. And then we put a layer of compost, fertilizer, mycorrhizae, and now biochar, which I'll get to in a minute, on the top of that soil, and then blend it all together. And that, by incorporating the organic matter, that will help keep those pores open. Obviously, it's going to settle a little bit. Yeah, 6 to 8 inches is what we aim for. Treatments for soil compaction, sort of our recommendations, and these do depend on the species and site. But if you have not terribly compacted soil, just coming in with mulch and maybe soil injection or fertilizer can do a lot. That mulch, I'm going to say a lot of good things about mulch as we go along today, but this is one thing we know about it. It can reduce low levels of compaction. The vertical mulching didn't work very well for us, and other people have done this sort of research too, and they've come up with the same results. Not very effective. And I think this comes down a lot of times to a numbers game. If you do the math on that spacing that I was telling you, it's about 0.5% of that rooting area. And again, we're making assumptions about the rooting area, drip line sort of area, and depth. But it's a pretty small number. And it's basically too small to have a big impact. With the radial trenching, we did see an impact there. And that's at about 5% of that root area affected. So that can be an effective treatment, and that's an option for those sites that are too heavy to cut with air, as you can come in with a trench, but you are going to do some root damage there, so it's a bit of a trade-off. And then the root invigoration process, we say, affects about 50% of the root zone. And again, that's highly variable. We now do smaller ones, we do bigger ones. You can do 100% if you want, but more likely we're doing maybe 50%. So those numbers, I think, tell us a lot about the results that we'll get. Basically, the more area, the better. So one of the other things that we've been working on, Dr. Kelby Feit at our lab, working with Brian Schierenbrock at the Morton, is looking at biochar as a soil amendment. So they've been working on this for a couple of years. Biochar is very similar to charcoal. It is, you take vegetative, mainly byproducts. In our case, we're using pine wood killed by mountain pine beetle in Colorado. They're trying to get rid of that wood as much as possible. They put it in a barrel, basically, heat it up to a very specified temperature. I think it's around 500 degrees Fahrenheit. and it basically drives off a lot of the volatiles in the wood and leaves you with a product that looks a lot like charcoal. This is an electron micrograph of that wood after it's been heated up, and you still have that structure of wood, but maybe it's a little bit more open because some of these cell walls, so you all recognize this as a tree wood, and you can still see the cell walls in here. So a lot of pore space, and that's where this product should be helping us out. So if you incorporate it in the soil, it will increase that cation exchange capacity, again, because of the pore space. It'll help with water retention, and because of the CEC increase, we're going to be able to hold on to fertilizers a little bit better, so they're not going to be leaching through the soil. So they've been studying this in agriculture, here corn with the biochar and the same soil. But what really works best is the mixture of a biochar and a fertilizer. The biochar comes in, they call it hungry, ready to grab onto nutrients. So if you apply nutrients, it will hold on to those nutrients and release them slowly over time as the plant can pull them off. So in some of our pot research that Dr. Feit's doing down at our lab, seeing big differences in growth. This looks like gardenia. Again, in a pot study, the control here, the 5% biochar by itself. So this one didn't have the additional nutrients, and really on its own doesn't really do that much. But it's when you start mixing compost in there and nutrients that we start seeing the real growth response from that product. And the difference between the biochar and just organic matter is the longevity in the soil. Because it's been heated, it's not going to break down as far, which is almost counterintuitive. But they've actually looked at agricultural land where this sort of process has occurred hundreds of years ago, and it's still there. The carbon is still there in the soil. So it doesn't break down as quickly as organic matter that hasn't been treated that way. So a couple of good things. One, it's a reservoir for carbon in the soil, which is actually one of our biggest reservoirs for carbon anyways. And two, it will give good growth response. And they're also looking at things like insects and diseases. And we're seeing some reductions, actually, in insects and diseases on the plants grown in biochar. I'm not sure exactly why that is, but there are several papers out there that are studying that and finding positive results. We incorporate this mostly with that root invigoration process. We are also doing a soil injection. This gets the level up much higher, much more quickly. Dr. Feit's done some calculations what it would take to do a soil injection of a powdered form of biochar, and it's like 17 years if you're doing it twice a year. So it takes a lot of soil injection to get it in there. But this is all done in one day, and it should start giving those benefits off pretty quickly. Going back to mulch. Again, I hope everyone's seen this slide on the right. Mulches do a lot of good things. The slide on the right from Dr. Gary Watson at the Morton showing root development under mulch. So he took soil cores from mulch and from grass, and he washed out all the soil and just left the root component. So he'd do like half the tree and mulch, half in turf. Tremendous increases in that root development. We see the same thing with root invigoration. Now, Gary's study, I think, took like 5 years or something like that. It was a multi-year study. We can see this change with the root invigoration quite often in a year or so with that changing soil. But we do need that mulch on the top to keep feeding that organic matter, unless you're doing the biochar, and then you don't have to do it as much. But again, mulch, very good thing, and it has a lot of other benefits as well. So we really like to see trees with mulch, not to the first limb, by the way, okay? You know, just spread out. We do like to see that root flare, and that's a big emphasis for our company this year, is looking for root flares, and I hope that you will too. We need to see the root flare from a health perspective because they did not evolve to fight off root decay pathogens, okay? The root flare is part of the trunk, and if it's buried, decay fungi, Phytophthora can come in to those root flares. So soil compaction, best thing to do is prevention. Preserve that soil on site as much as you can. We know there are limitations there. We know you don't always have that luxury, but certainly that's where we need to start. There are other methods of working with soil, especially if there aren't existing trees, coming in, subsoiling, rebuilding that soil profile. A lot of work at Virginia Tech on this. Again, this sort of process, subsoiling, then working up the top 6 or 8 inches with a tiller, working in organic matter, rebuilding that natural soil profile, can work really well. It just can't work with existing trees, but it certainly can work if you're in an area where you have no trees.